Good day, my name is Ralph Roger Dayao. Today I'm going to discuss the fundamentals of basic electrical engineering. This is the atomic structure of a copper. A copper has a amount of 35 neutron, 29 proton, and 29 electrons. A copper has a valence electron of 1. Valence electron is the outermost part of a atom. Electric charge and electric current. 1 electron is equal to 1.6 times 10 raised to negative 19 coulomb. 1 coulomb is equal to 6.24 times 10 raised to 18 electrons. Note that when 1 coulomb of electric charge continuously passes a given point per second, the electric is said to be 1 ampere. Therefore, 1 ampere is equal to coulomb per second. Kumbaga, kapag yung column, ginawa mong per unit of time o ginawa mong rate, magiging ampere siya. Kaya 1 ampere is equal to 6.24 times 10 raised to 18 electron per second. Roughly, sabi dito, 1 ampere is equal to 6 billion electrons that is passing to a certain point per second. A current. Current is the rate of flow of electric charge measured in amperes, which yung I is yung current, yung Q is yung electric charge per unit of time. In seconds yun. Ito naman, electric drift velocity. The formula of electric drift velocity is equal to VD is equal to I over ENA. Where yung I is yung current, yung E yung charge of electron, yung N yung number of electrons, yung A yung area of cross-section ng conductor. Next tayo. Ito, dimensional analysis ng electric drift velocity. So, ipakita natin kung bakit naging ganun. Dito sa electric drift velocity, equal yan sa I, which yung ampere, sabi nga natin kanina, over dito sa electron over cubic meter, ano ba yan? Yan yung E. Multiply by dun sa area na square meter, tapos multiply dun sa dun sa N. Dito, simple kung bakit naging ganito, electron over cubic meter multiply by square meter, cancel natin tong cubic meter. Cancel to, matitira dito, meter. Dito, pag minultiply naman natin electron over meter, dito, magka-cancel tayo dito. Cancel natin electron, ang matitira dito, coulomb per meter. Ito. Ngayon, kaya nag-come up dito, 1 over meter multiply by coulomb. Ngayon, pagka ano na yan, cancel natin tong coulomb. Ang mangyayari, magiging 1 to, magiging 1 to. Yung numerator, parang dito, extreme over means lang tayo. Kaya makukuha nating sagot dito is eto, meter per second. Next tayo. Calculate the drift velocity of electrons in a 12-gauge copper wire which has a diameter of 2.053 mm, carrying a 40 ampere current. Given that there is 1 free electron per copper atom, the density of copper is 1.4 times 10 raised to 3 kg per cubic meter. The given is N is equal to 1 electron per atom. The diameter is equal to 2.053 mm in a 12-gauge copper wire. E is the constant which is 1.6 times 10 raised to negative 19 coulomb per electron. And the current is equal to 40 amperes. To compute this, to get the electric drift velocity, we have to convert 1 electron per atom to electron per cubic meter. So, para convert yan, mumultiply natin tong 1 electron per atom sa 6.2, 6.02, 6.02 times 10 raised to 23 atoms over 1 mole. Kaya dyan, makakancel tong atom, magiging mole siya. Tapos yung mole, para may convert natin siya sa gram, 1 mole is equal to 63.54 grams. Cancel naman dito yung mole. Tapos yung grams, para ma-convert natin sa kilogram. Para ma-convert natin sa kilogram. Ano dito? Para ma-convert natin sa kilogram tong grams, 1,000 grams divided by 1 kilogram. Cancel tong grams. And then, multiply natin siya dun sa, ay, mahirap. Hindi ako sanay gumamit na. Multiply natin siya dun sa given na density, which is 1.4 times 10 raised to 3 kilogram per cubic meter. So, kilogram per cubic meter. Ayan. Ang makukuha nating sagot dyan, multiply natin to. 6.02 times 10 raised to 23 divided by 63.54 equal to times 1,000 times 1.4 times 10 raised to 3. So, ang makukuha nating sagot doon is 1.326 times 10 raised to 28. Yun yung N. Tapos sa diameter, para makuha natin yung diameter, ay yung area. Ang formula ng area is equal to pi r radius squared. Dahil diameter ang given, ang area natin is magiging pi d squared over 4. Direct substitution lang. Pi multiply by 2.053 millimeter squared over 4. Ang sagot dyan sa area is pi multiply by 2.053 raised to 2 equal to divided by 4. Ang sagot natin sa area, ang area natin is 3.31 times 10 raised to negative 6 square meter. So, yan. Kumpleto na yung ano natin. Meron na tayong area. Meron na din tayong yung N, nakuha na din natin. In ano to? In electrons per cubic meter. So, substitute na natin dun sa given formula na electric drift velocity is equal to the current. Current is 40 amperes. 40 amperes divided by yung area natin which is 3.31 times 10 raised to negative 6 multiply by 1.6 times 10 raised to negative 19 times itong n natin which is 1.326 times 10 raised to 28. Ande ang makukuha natin doon. 40 divided by 3.31 times 10 raised to negative 6. 3.3 raised to negative 6 multiply by 1.6 times 10 raised to negative 19 times 1.326 times 10 raised to 28. Ang magiging electron drift velocity natin, VD is equal to 5.696 times 10 raised to negative 3. Raised to negative 3 meter per second. Meter per second. Ayan. Ayan. Yan yung sagot. Galing nga yung laro. So, ayan. Sa electric hazard, sabi dito, ang 1 milliampere, ang epekto niya is barely perceptible. Perceptible. Kumbaga parang shock lang. So 1 to 3 milliampere, perception threshold most cases. Dito sa 3 to 9, makakaramdam ka na ng pain. Habang tumataas, mas nagiging fatal yung effect nung so, ayan na nga. Next. Ayan. So, conduction electron density comparing sa energy sa material. Dito kinukuha yung value. Electric wire standard. American wire gauge or AWG is also known as the Brown and Sharp wire gauge is logarithmic step standardized wire gauge system used since 1857 predominantly in North America for the diameters of round solid non-ferrous electrically conducting wires. Dimensions of the wires are given ASTM standard. The cross-sectional area of each gauge is an important factor for determining its current carrying capacity. Ampacity. The rules of thumb. The sixth power of 39 square root of 92 is very close to 2, which leads to following rules of thumbs. Ganyan. Diyan, kinukuha yung value nun. Dito yung laki ng yung size pala ng wire. Dito yung diameter in inches, millimeter squared. Ayan. IEC 60228. IEC 60228 is the International Electrotechnical Commission's international standard on conductors of insulated cables. As of 2020, the current versions of third edition 2004 to 11, among other things, it defines a set of standard wire cross-sectional areas. In engineering applications, it is often most convenient to describe a wire in terms of its cross-section area rather than its diameter, because the cross-section is directly proportional to its strength and weight is inversely proportional to its resistance. The cross-sectional area is also related to the maximum current that a wire can carry safely. Yan. International standard wire size dito yan. Dito ko nakuha. Sa solid wire versus stranded wire, sabi dito, yung pros ng ano, yung ang mainam dito sa stranded wire, bundle braids of stranded cables offer a few acute benefits over solid wire. Sabi dito, yung stranded wire flexible, malleable, will not split or sever. Hindi siya mabilis maputol, kumbaga. Yung stranded wire, most suited siya sa mga indoor application, sa mga gaya ng circuit boards, speaker wire, electromechanical assemblies, dun siya ginagamit kadalasan. Solid wires naman, pros niya, weather resistant siya, anti-corrosive, tapos low cost, mura, kumbaga. Solid wire application, sabi dito, most suited siya sa indoor, sa mga heavy duty application, gaya ng building infrastructure, vehicle controls, outdoor application. Iba-ibang sinasabi niya. So, sabi dito, resistance and resistivity. Electrical resistance is opposition to the flow of current in an electric circuit. Resistance converts electrical energy to thermal energy. In this regard, it's similar to mechanical friction. Yung resistance are said to dissipate electrical energy as heat. The unit of resistance is ohm. Ito yung unit niya. The higher the resistance, the lower the low it's capable of conducting a current, and vice versa. The resistance of an object is dependent to the temperature, kind of material, cross-sectional area, the length and temperature. Next, electrical resistivity, also called specific electrical resistance or volume resistivity, and its inverse electrical conductivity, is a fundamental property of a material that quantifies how strongly it resists or conduct electric current. A low resistivity indicates a material that readily allows electric current. Resistivity is commonly represented by the Greek letter, yun yung parang P, o tinatawag nilang Rho. The SI unit of electrical resistivity is ohmmeter. Ito, ohmmeter. For example, meron kang 1 meter solid cube of a material that has a sheet contacts two opposite faces. Tapos yung resistance niya between these contacts is 1 ohms. Then yung resistivity ng material is 1 ohmmeter. Kasi i-multiply mo lang siya. Its measurement affected by the following: klase ng material tsaka sa temperature. Yan. Yung formula ng resistance is R is equal to rho length over the area. Sa resistivity naman, ganun din. Kumbaga, parang sa algebra, minultiply mo tong A both sides para makancel to. Parang minultiply mo yung A dito. Tapos magkakaroon ng A dito, makakancel to. Ngayon, para makuha mo yung formula na to, i-divide mo lang to sa L. Ayan. Cancel to ngayon, ang makukuha natin ito. So, ayan. The resistance, yung dito, sabi dito, yung R yung wire resistance, yung A yung cross-sectional area, yung L yung wire length. Tapos, yung rho, yun yung resistivity natin. So, next. Dito, halimbawa, area in circular mills, cm. Sabi dito, pagka halimbawa, mayroong diameter na ganito, binigay yung area is equal to diameter squared. Where yung area is equal to cm. Yung diameter sa mills. Kumbaga, pag binigay ka ng 1 inch, o kaya 2 inch, multiply mo lang siya sa 1,000 mils. Tapos, squared mo siya para makuha mo yung, ano niya, yung area. Dito, ito, dimensional analysis naman to ng ano, sa resistance. Kumbaga, ano ba natin yan ito? Sa SI unit, meron tayong, ito, ohmmeter. Ito yung raw, yung resistivity. Kumbaga, pag minultiply natin to dito, di ba, ang makukuha natin, ohm meter squared. Meter squared over meter squared, di syempre, cancel yan. Ang matitira dito, ohms. Dito naman sa American customary system, dito, ito, pag minultiply mo dyan, makakancel to. Cancel din tong circular mills. Ang matitira pa din dito, ohms. Ayan. Ayan. So next, sample problem natin dito ay 500 feet length of silver wire has a resistance of 20 ohms. What would be the resistance of an copper of a similar cross-sectional area having a length of 1,000 feet? And how long should the copper wire be if it is have to be the same resistance as the wire? Yan. Paano nga ba yan? Ang given natin dyan, may given tayo na so ayun, pare-tuloy natin. Ang given natin dito is sabi dito, merong length na 500 feet. Length of silver wire. Tapos may resistance siya na resistance is equal sa 20 ohms. Silver wire. Hindi natin kukunin yung resistivity niya. Resistivity niya is dito natin kukunin. Hindi yung resistivity ng silver. Ito. 9.6. 9.6. Yung raw niya is 9.6 cm ohms per feet. Tapos, yung para ang sabi dito, ang nawawala sa kanya, sa mga given niya, area. Area is equal to unknown. Para makuha natin yan, mag-formulate tayo galing dito sa resistance is equal to resistivity multiplied by length over the area. Cross multiply natin siya. Kakaroon tayo ng resistance times yung area equal to resistivity times yung length. Ngayon, para makuha natin yung area, i-divide natin yung resistance. Cancel natin yan. Area equal to raw length over the resistance. Ayan. Area natin is equal to yung raw is 9.6 multiply by 500 feet divided by yung resistance natin 20 ohms. Ang area natin mako-compute dyan is 240 cm. cm. Bakit cm? Kasi feet to. Tapos ito, cm, ohms over feet. Cancel to. Tapos ito, makakancel yun nandito. Yung ito sa 9.8. Tapos yung ohms nito, cancel dito sa baba. Matitira, ito, cm. So yun, meron na tayong 240. Yan natin to. Tapos sabi din sa kasunod, what would be the resistance of an copper wire of similar cross-sectional area having a length of 1,000 feet? Sabi dyan, ano daw yung resistance ng copper wire? Daw magkamukha, ito daw yung gagawin. Ito yung gagamitin natin, similar cross-sectional area. Tapos may length siya na, length na equal sa 1,000. 1,000 feet. Doon nahihirapan na rin ito. Ede, ayun nga. Copper wire naman yan. Kukuhanin natin yung resistivity ng copper wire dun sa kanina, dun sa table. Ang resistivity ng copper wire, ito, anode copper, gagamitin natin. 10.37. So, yung gagamitin natin yung 10.37. 10.37. Yun yung raw. Tapos, parang, ang kukuhanin natin dito yung burahin muna natin to. Burahin natin kung hindi rin tayo. Ilan tayong spaces. Ito, nakuha natin yung given para dito sa tanong na what would be the resistance of an copper wire of similar cross-sectional area having a length of 1,000 feet. So, gamitin natin yung resistance is equal to itong resistivity, yung rho, multiply by length over area. So, ang magiging mangyayari dyan, ang rho natin is 10.37 cm ohms per feet. Multiply by dun sa length na 1,000. 1,000 feet. So, ayun, divide natin sa area na 1,000 ayun sa sa area na 2,240 circular mil. So, para ano yun, tanggalin natin dimensional analysis, cancel to, cancel tong feet, matitira sa atin, resistance is equal to resistance ng copper wire na may similar cross-sectional area equal to 43.21 ohms. So sabi dun sa kasunod, and how long should the copper wire be if it is to have the same resistance as silver wire? Sabi daw, ano daw, gano'n daw kahaba yung copper wire kung meron daw siyang same resistance na itong silver wire. Ito yung sinasabi doon, yung 20 ohms. So, bali ang mangyayari dyan, ang hinahanap dito is yung length. Length ang hinahanap. Ang area na gagamitin natin dito is ito pa rin, yung nakuha natin dito sa una na 240 circular mils. Tapos, resistance na 20 ohms. Tapos, yung itong resistivity ng copper, which is 10.37 cm ohms over feet. So, erase muna ulit natin ito. Ano muna natin yan. Coming dito sa dito sa formula uli natin, resistance is equal to rho length over dito sa area. Multiply lang natin area resistance equal to rho. Okay, tapos divide natin itong rho dito para cancel ito. yung length natin is equal to area times the resistance over resistivity. So, substitute lang natin. Meron tayong area which is into 40 cm. Tapos, multiply natin sa resistance, which ito yung 20 ohms. Over dun sa dun sa resistivity natin, which is 10.37 cm. cm o per feet. Ayan. Cancel kong ohms, cancel kong cm, matitira natin, extreme over yung ulit, iangat natin yung feet, matitira natin, length natin is equal to 462.87 feet. Ito yung length niya. If copper wire has the same resistance as yung silver wire. Yun. Okay. Next natin. Ayan nga. Yan natin kinuha yung kanina. Yung resistivity ng mga mga material natin. Example. Temperature effect on resistance. Material that are classed as conductor tends to increase their resistance with an increase in temperature. Insulator, however, are different. It tends to decrease their resistance with an increase in temperature. Materials used for practical insulator such as glass, plastic, etc. only exhibit a marked up drop in their resistance at very high temperatures. They remain good insulators. Overall temperatures, they are likely to encounter in use. The higher the temperature, the more violent the atoms vibrate. In conductor, which already has a large number of free electrons flowing through it, the vibration of the atoms causes many collisions between the free electrons and the active electrons. Each collision uses up some energy from the free electron and is basic cause of resistance. The more the atoms scrambling around in the material, the more collisions are caused, and hence the greater the resistance the current to flow. In an insulator daw, however, there is a slightly different situation. There are so few free electrons that hardly any current can flow. Almost all the electrons are tightly bound within their particular atom. Healing an insulating material vibrates the atom, and if heated sufficiently, the atoms vibrate violently, enough to actually shake some of the captive electrons, creating free electrons to become carriers of current. Therefore, at high temperatures, the resistance of an insulator can fall and in some insulating materials quite dramatically. Ayan. Resistance temperature detectors. Ayan, the relationship of temperature and resistance of conductor can be calculated from ito, yung equation na to. R is equal to R sub O multiplied by 1 plus ito yung coefficient resistance sa temperature multiplied by delta T. The difference between the operating reference temperature. Temperature effect on resistance. The inferred absolute temperature is the temperature at which a system is in the state of lowest possible minimum. Energy as molecules approach this temperature, their movements drop towards zero. It is the lowest temperature a gas thermometer can measure. No electronic devices work at this temperature. The kinetic energy of the molecules become negligible or zero. Kumbaga, ito, dito natin kinukuha yung value ng mga inferred absolute temperature. Yung coefficient temperature dito. Ito yung mga material. So, ito. Meron tayong example. May example tayo dito. A piece of copper wire has a resistance of 40 ohms at 14 degrees centigrade. What is the maximum operating temperature if the resistance of the wire is to be increased by 10%? Assume that the coefficient temperature is 14 degrees centigrade equal to, ayan, ito yung value. Mga ang given natin is R1. Ito. R1 is 40 ohms. Yan. At 14 degrees centigrade. Yung resistance 2 natin, sabi dito, nag-increase siya ng 10% sa unang resistance. Kaya ang nangyayari, 40 ohms plus 10% ng 40 is 4. Kaya ang makukuha nating resistance is 44 ohms. Tapos may given tayong temperature na may given tayong temperature. So ayun, meron tayong T. Ang dapat to 14 degrees centigrade. Dito, million. So ayun, T sub 2 yung mawawala. I-next natin. Okay, kami din sa formula na R equal to R sub O multiplied by 1 plus yung coefficient of temperature plus delta T. Yan. So, ayun. Input lang natin yung data natin. Yung mga given naman parehas ng meron tayong itong 44 yung R sub 2 at R sub 2 to 44 ohms is equal to 40 times 1 plus yung natin ito is 0.0.01 0.0041. I-multiply natin sa delta T. T sub 2 yung nawawala. T sub 2 minus T sub 1 is 10 degrees centigrade. Ayan. So, i-divide muna natin to. I-divide muna natin sa 40. Divided by 40. 44 over 40. Itong 1 naman, pagkatapos natin i-divide, transpose natin to dito. Ngayon, i-minus natin yung 1. So, i-minus yung 1. I-divide, i-multiply natin ulit dito. So, divide natin ulit dito sa 0.01 over 0.0041. Patatanggal din naman to. Ngayon, ang matitira dyan, equal na yan sa T2 minus 10 degrees centigrade. Pag nilipat natin to, magiging plus lang to. Ganun. Ang makukuha natin sagot dyan, yung T sub 2. T sub 2 natin, equal yan sa, ano natin, compute natin. 40 divided by 44 divided by 40 minus 1 divided by 0.0041 plus 10. Ang makukuha natin dyan is 34.39 degrees centigrade. Ayan yung T2 natin. Ayan. Natin. Next natin. Ito. A heating element made from tungsten has a resistance of 16 ohms at 1,500 degrees centigrade. Find the resistance at normal room temperature. Normal room temperature natin. Kanina, 20 degrees centigrade. So, ayun. Tungsten natin kukunin yun. Natin. Dito yun. Dito natin ginuha yun. So, dito, ang pag-compute natin dito, given natin is R2 is equal to 16 ohms. Yung T sub 1 is 20 degrees centigrade. Temperature 2 is 1,500 degrees centigrade. Tapos, ang mawawala natin yung R1. So, yung R natin dito yung R2, equal natin yung sa R sub O, yung R sub 1, multiply by 1 plus the coefficient temperature, multiply by sa delta T. Delta T. Yan. Para makuha natin itong R sub 1, kasi yun yung hinahanap, i-divide natin ito sa 1 plus coefficient temperature times delta T. Para makancel to, mapupunta to ngayon dito. Ngayon, yung R sub O natin, magiging equal siya sa R over 1 plus the coefficient temperature times delta T. Tapos direct substitution lang tayo dito. Resistance natin ng R sub 2 is equal to 16 ohms. Divide natin siya sa 1 plus yung coefficient temperature ng tungsten. Hindi natin siya kukunin. Dito natin siya kukunin sa infrared. Dito. 0.005. 0.005. 0.005. Tapos, multiply yan sa delta T, which is T higher over T higher minus T lower. 1,500 minus 20 is 1,480 degrees centigrade. Ngayon, yung R sub 1 natin is equal to 16. Ikutin natin yung baba ng 0.005 times 1,480 equal to 7.4 plus 1, 16. Right? Ang resistance niya is 1.905 ohms. Yung resistance niya. Okay. So, electric circuit. Electric circuit path for transmitting electric current. An electric circuit includes a device that gives energy to the charged particles constituting the current, such as a battery or a generator device that uses current, such as lamps, electric motors, or computers. And the connecting wires or transmission lines, two of the basic laws that mathematically describe the performance of electric circuits are the Ohm's law and Kirchhoff's law. Ayan. Sa electric circuit, sa battery, meron tayong supply. Ito, battery. Resistor, switch, control dun sa taloy ng kuryente as yung bulb. DC current. A circuit containing a battery is a DC circuit. In a DC circuit, the current always flows in the same direction. Kung makikita natin, kahit saan siya magpunta, yung flow nung current niya is parehas lang. Kumbaga kung nandito yung positive, magiging galing dito yung daloy ng current natin. Kahit mapa sa kabila nun siya. So, dito, DC circuit, Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points, introducing the constant of proportionality, the resistance. One arrives at the usual mathematical equation that describes this relationship where I is the current through the conductor in units, ampere. So yung coulomb per second natin. Voltage is V is the voltage measured across the conductor in units of volts. And lastly, yung R is the resistance of conductor in units of ohms. More especially, Ohm's law states that R in this relation is constant, independent of the current. Kaya, kumbaga, ang sinasabi lang dito, pag tumaas yung resistance natin, bababa yung electric current natin. Pagka bumaba naman yung resistance, tataas yung electric current. Independent sila to each other. So, ayan. Formula ng Ohm's law. I is equal to V over R. Ayan. Ito yung mga natin. Mga SI prefixes. Pero tayong iota, theta, eta, peta, tera, giga, mega, kilo, hecto, deka, deci, centi, mili, micro, nano, pico, cento, ato, septo, yokto. Ayan. Mga prefixes natin. Sa Ohm's law, ito na, dito na tayo. Sample ng Ohm's law. A 10-volt battery supplies power to a cordless iron with a resistance of 20 ohms. How much current is flowing through the curling iron? Formula natin, kagaya nung sinabi ko kanina, ang formula natin sa Ohm's law is the current equal to voltage over the resistance. Substitute lang natin yung sa formula, meron tayong 10 over 20 is less than 1 half or 0.5 amperes. Amperes yan, amperes. So, ayun, ito na yung final answer natin, 0.5 amperes. So, dito, sabi, a CD player with a resistance of 40 ohms has a current of 0.01 amperes. Flowing through it, sketch the circuit diagram and calculate how many volts supply the CD player. So, ang natin dyan, meron tayong volts dito. Tapos, yung resistance natin dito. Tapos yung flow ng ano natin, ng current is ganyan, is equal to 0.01 amp. Tapos resistance equal to 40 ohms. Saka yung formula ng ohms to is I over B over R. Para makuha natin yung V, cross multiply lang natin yan. V is equal to I current over R. P natin, substitute lang natin yung mga value. 0.01 multiply by 40 ohms. Voltage is equal to 0.001 times 40. 0.04 volts. So next natin, waste naman natin. Dito meron tayong pinapakita dito kung paano yung series. Pinagkaiba ng series sa ng parallel. Sa series, diretso siya. Dito, sa parallel, dito magkakaduktong sa series. Yung resistance niya. Dito naman sa parallel, meron silang para magkakatapat. Ito yung traits of resistance in series. Sa resistance, yung arrange ng yung total, yung R total ng resistance sa series is equal to R sub 1 plus R sub 2 plus R sub 3 and so on. Ayan. Series circuit characteristics. Ayan, makikita natin dyan. Ito yun, yung R total ng resistance sa current ay yung I total is equal to volt over R total. And so on. Dyan. Sa traits of resistance in parallel, ang inano naman nila, yung pinagkaiba naman niya sa series, itong sa parallel, parang kumbaga reciprocal siya nung ng ng resistance dun sa series. Kung yung R total ng series is equal lang siya sa R1 plus R2 plus R3 and so on, ito naman ang pinagkaiba niya, ang niya, 1 over R total is equal to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 and so on. Sabi dito, current is distributed on each resistor. The total current or the I sub T is equal to the sum of the current across the resistor. Ayan, sabi, I total is equal to I sub 1 plus I sub 2 and so on. Sa voltage naman, the voltage is constant. The voltage across each resistor is equal to the supply voltage. So Vt is equal to V sub 1 plus V sub 2 and so on. And then, ang pinagkaiba nga lang niya, yung sa resistance niya is naka-fraction. Kasi nga reciprocal siya nung sa series. Ayan, for two resistance in parallel, yung R sub T niya is equal to, ayun, R sub 1 multiply by R sub 2 over R sub 1 plus R sub 2. Sabi dyan. So, next natin. Ito, dito tayo sa sample problem natin sa series and parallel circuit. Sabi, what resistance X in parallel with resistance of 100 ohms and 200 ohms give an equivalent resistance of 50 ohms. Then, ang formula natin sa resistance ng R sub total is equal sa 1 over R sub total equal to 1 over r sub 1 plus 1 over r sub 2. So, dalawa lang naman yung ano natin, yung resistance. So, i-add na lang natin tong 1 over yung x. Dito, yung hinahanap ng resistance na x. So, para makuha natin yung x, transpose lang natin to, itong dalawang to, which gives us 1 over x is equal to, substitute na natin yung mga value nito, given na ohms, 1 over 50 ohms. 1 over 50 to, 50 ohms. Minus to, minus, kasi transpose natin yung dalawang value. 100 ohms minus 1 over 200 ohms. So, ang pagkuha natin dito, kuhanin lang natin yung least common denominator niya. LCD, 200. Tapos, i-divide natin sa 50. 200 divided by 50, 4 times 1, 4. Tapos, 200 divided by 100 is 2 minus 2. 200 divided by 200 is 1. Minus 1 lang. So, ang makukuha natin sagot dito is 1 over x is equal to 1 over 200. So, para makuha natin yung x, get lang the reciprocal, get the reciprocal, reciprocal, x is equal to 200. 200 ohms. Ayan. Ito na yung final answer natin. Erase din natin. So, ayun. Next tayo. Sabi dito. Determine the equivalent resistance of two resistors of 12 ohms and 18 ohms when they are connected in parallel and in series. Para dito sa ano, sa parallel circuit natin, ang formula natin dahil kanina is 1 over R total equal to 1 over R1 plus 1 over R2. Pag sinubstitute natin dyan, meron tayong 1 over 12 plus 1 over 18. Tapos yung LCD niya is 36. Divided na dito. 1, 3 plus ito, 2. Sagot natin dyan is 5 over 36. Parang pag kinuha natin reciprocal, R total niyan equal to 36 over 5 ohms or 7.2 ohms. Tapos yung sa ano naman, dito naman sa series R sub total is equal to R sub 1 plus R sub 2. Kailangan lang natin gawin dyan, i-add natin yung dalawang resistance, which is yung 12 plus 18 ohms. Tapos talaga yung sulat dito. Yung R total is equal to, ito yung sa parallel. R sub total natin is equal to 30 ohms. Raise natin. Tapos next. Ayan, dito naman. Dito tayo sa ano. Sabi dito sa series. Find the current in the circuit below. Meron tayong given na 6 volts sa supply. Meron tayong given na resistor 100 ohms saka 400 ohms in series. Saka meron tayong dalawang resistor din na in parallel. So, para makuha natin 'yan, kailangan natin gawin given natin yung volt. Total is equal to 6 volts. Tapos, our total natin is equal to ito, yung 100 ohms plus 400 ohms in 500 ohms. Yan yung sa series. Ito yung sa series natin. Para makuha naman natin yung sa isa, dun sa dun sa parallel, 1 over RT equal to 1 over 100 ohms plus 1 over 200 ohms. So, ganun lang din. Extreme over means lang ulit tayo. Meron tayong 200 divided by 1. Meron tayong 2 plus 1. 1 over RT is equal to 3 over 200. Reciprocal niya is RT is equal to 200 over 3. Tapos, para makuha natin yung total ulit, our total, ipag-add lang natin yung dalawa, na-compute natin, 500 plus 200 over 3, which is, ito natin, 566.27 ohms. Yun yung our total natin. Ngayon, para makuha natin yung I total, equal yan sa V over R T. Given natin na V is equal to 6 volts over our total natin is 566.57 ohms. So, I natin is equal to 0.011 ampere. Ayan, ito. Sulit. Ayan. Next problem tayo. Sabi dito sa next problem, find the current I in the circuit below and the current passing through each of the resistor in the circuit. So may given tayo dyan May given tayo na volt total is equal to 7 volts. Tapos, yung yung ating volt is parallel. So, yung R total natin is equal to 1 over 100, 100 ohms plus 1 over 400 ohms plus 1 over 200 ohms. Tapos, ayun nga, kailangan natin kuhanin yung LPD. LCD niya is 400 ohms. So, 400, divide natin dito. Nakuha natin 4 plus 4 plus 1 plus 2. So, kuha natin ng 1 over R total equal to 7 over 400 ohms. So, yung R total natin, R total, reciprocal lang, is 400 ohms over 7. 400 over 7 ohms. Yun yung R total natin. So, para makuha natin yung current, given naman na yung volts, ay total equal to V E over RT equal to 7 volts over 400 over 7 ohms. Ohms. Equal yun sa 0.1225. So, ayan. Dito natin siya. So, sabi dito, and the current passing through each resistor. It means, kada resistor, kukumputin natin kung ilan yung loads niya. So, para ano natin yan, yung I1 natin is, ito yung R1 natin is equal to V over V1 over R1. Ano ba? Tama. So dito, equal lang naman yung volts dyan. So, equal yan sa 7 over 100 ohms. Equal to sa 0.7. 0.07. Tapos, ganun din sa I2 natin, equal yan sa 7 over 400 naman. 400 equal to sa 0.175 amps. 0.175. Tapos, I1, I2, tapos meron tayong I3 equal to V sub 3. V sub 3 naman yun over V R sub 3. Equal yun sa 7 over R sub 3 natin, 200 ohms. Equal yun sa 0.035 ohms, ay amps. Ampere. So, kailangan itong nakuha natin na I sub 1, I sub 2, ka I sub 3, pag pinag-add natin, pag kinuha natin yung total niya, kailangan ang makukuha natin is yung I total, yung 0.1225. So, add natin lang tong 0.7 amperes, 0.07 amperes, 0.175, 0. Ano, 0 pala tayo dito, ng 0. 0.0175 tsaka 0.035. Ito. Pag pinag-add natin sila, 0.07 plus 0.0175 plus 0.035, ang makukuha natin ito. 0.1225 ampere. Ayan, kaya na natin. Ayan. Thank you. Thank you.